we're going to return to the topic of factoring. We're going to look at, instead of factoring perfect squares or sum or difference of squares, we're going to look at sum and difference of cubes. So our objective is that we can factor sum and difference of cubes. So first of all, let's take a look at this pattern. These two patterns, sum of cubes and difference of cubes. First of all, you just have to recognize the fact that when you have a cube and there's a sum, you're going to use this pattern. And when there's a cube on each of these and there's a difference or a subtraction, you're going to use this pattern. Now look at what happens with these patterns. When there's a plus here, there's a plus here, and then a minus here. When there's a minus here, notice it's replicated there with a minus here, and then it switches to a plus. So that is a pattern that you can use when recognizing these. Both of them have the last term being added to it. Now notice that these are, when we have cubes here, this is the linear version of it for both of these. And then you have the square on the first and last term and the trinomial at the end. And then you just multiply the two of these together for the middle. Another thing we need to make sure we use is a list of cubes. You have to be able to look at a problem and recognize when one of these cubes are being used. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, and then another often used one is 10 cubed is 1,000. So when looking at these, let's go ahead and put these into practice when it comes to a demonstration of how these are used to do problems. So if I ask you to factor this binomial, you first of all recognize that there's a cube on it, so we're going to use one of these two, and there's an addition there, so we're going to use this first pattern. Now notice, if this is the case, you want to look at and recognize that this 8 is 2 cubed. And so what you have when you factor it is you're going to take, it's going to be x plus 2 to start with, because you take the cubes off of them. So 2, you take that and put it in this pattern. And now I'm going to have a trinomial where I'm going to square the first one, x squared. I'm going to square the last one at the end. So square the 2 here. So 2 squared is equal to 4. And then in the middle, I'm going to put minus these two multiplied together. So 2 times x. So the pattern you just put in is recognizing that the x is the first term, goes in both these spots. 2 is the one we pull down from that one. Let's try it with this one. This one's a little more complicated. So I want you to recognize that this is the same as 6n cubed, because if you cube 6, you get 216, and n cubed. And this is the same thing as 5p cubed. So I've got the difference of 2 cubes, where 6n is my first piece of it, 5p is my second. I'm also recognizing, since there's a minus in the middle, you've got to use the second pattern. So the first thing I do is put a parentheses, and then we're going to have a binomial parentheses and a trinomial parentheses. We take these two, whatever's being cubed, 6n, and we're going to subtract the second one being cubed, the 5p. So 6n minus 5p for the first one. And then the second part here is I'm going to square each of these. So I'm going to square 6n, squaring 6 gives me 36. And then I'm going to have an n squared. Now square the last one and put it at the end. So I'm going to have plus, always plus at the end. Square the 5, you get 25. And then square the p and you get a p squared. And in the middle, when this is a minus, I'm going to make this into a plus. Notice that's the pattern here. Minus there becomes a plus there. And then it just says multiply whatever these two are here. So I'm going to multiply the 6n and the 5p. That's going to give me 30. And then I'm going to have np there. So my factorization, I have a binomial, a trinomial for that. And I just break down what is the a and b in these two. You might even want to put down that A is equal to 6n and B is equal to 5p and just substitute those into this pattern to simplify. Now what I'd like you to do is I'd like you to pause the video here and I'd like you to try these two. See if you can get a start on these two, see if you can get these factored, and then once you pause the video and tried it, I'll come back and work them out with you. Hopefully now you've tried each one of these. Let's take a look at what these factor into. So the first one here, I'm going to use the difference of cubes. The difference of cubes pattern, remember, is going to be a minus b for a cubed minus b cubed. Okay, it's going to equal a minus b times a trinomial. It's going to be the first one squared, the last one squared, and then if this is a minus, I'm going to add these two multiplied together, just a times b. So let's see if we can do that with this. Notice I've got x cubed, and this is equal to, this is the same as 5 cubed. So in order to factor that, I'm going to put a binomial and a trinomial. My binomial will just be each of these without the cube. So x minus 5 for each of those. Then for the trinomial, I'm going to square the first one, x squared. I'm going to square the last one, that's 25. And then whatever this operation is, I'm going to switch it. So this is going to be a plus, and then just multiply these two together. It becomes 5x in the middle. So these two multiply together to give me that. Now, just to confirm it, this is the factorization. This is the answer to it. So let's go ahead and confirm that these two multiply to get this by going ahead and multiplying it through. This is the final answer to factoring, but let's confirm it by multiplying through. So we're going to distribute through the x to each one of these three. X times x squared is x cubed. X times 5x is 5x squared. X times 25 is 25x. Now let's distribute through the negative 5 to each of these. Negative 5 times x squared is negative 5x squared. Negative 5 times 5x is negative 25x. And then negative 5 times 25 is negative 125. Now what you can start seeing is that these two, they're opposites, they get rid of each other. These two are opposites, they get rid of each other, and so I end up with x cubed minus 125. So this pattern that we've developed with the pattern we have up here, these hold true because if you multiply it back out, the middle terms get rid of each other and you end up with just the cubes on the outside. So let's do the other one here. Hopefully you practiced this one and tried this one. It might be helpful to just say that your A in the pattern is equal to 3m, your B is equal to 4, because this is the same thing as 3m cubed plus 4 cubed. The pattern itself, for the sum of cubes, so a cubed plus b cubed, since they're being added here, is going to factor into a plus b times the quantity, the trinomial now, a squared. This is a plus, we change it to a minus here, multiply the a and the b together, and then the last term is always plus, and you're going to have the b squared out here. So let's use that pattern to factor this. You're going to have a binomial and a trinomial. The binomial, we're going to just take each one of these without the cubes on it, so 3m plus 4. Now in here you're going to have, I'm going to write it out in long form, then I'll simplify it. You're going to square this first one, 3m squared. Now the next, if this is a plus, you change it to a minus here. You multiply these two together, so you're going to have 3m times 4, if you multiply those out. And then lastly, you're going to have plus, always plus at the end. You're going to square the 4. Now let's just simplify those. So you can have 3m plus 4 times the quantity, and this one, when you square 3, you get 9. Square the m, you get m squared, minus 12m when you multiply those two, and then plus 16 at the end. So this is your factorization of that. Now I'm not going to multiply it out because our directions were to factor. This was just to confirm that this pattern actually works. So our objective was to be able to factor sum and difference of cubes. We've got a pattern that we can use. These two patterns will be the template for doing each one of these when we recognize that we've got a sum or a difference and the a and the b, or those terms, are being cubed. And that leads us to be able to take these very complicated looking polynomials and factor them, because they're two terms, they're perfect cubes for the first term and the second one, and there's a difference or a sum in the middle between them. So then we can factor them using the pattern.